There are three factors that the operator should consider. Number one, airflow direction. Number two, the volume of air. Number three, the speed of the air. The operator is able to adjust the air direction, carrying the droplets from the nozzle to the canopy. He's able to adjust this air direction by moving, in the case of this sprayer behind us, by moving the adjustable heads. This in turn adjusts the direction that the air will flow. So the volume of air produced by many traditional sprayers is far too large for modern vineyards and modern trellis designs, resulting in the spray going through the canopy and away, resulting in drift. And so what the grower should do is try and change the volume of air according to the canopy that exists whilst he's spraying. The grower can do this by various ways. He could buy a machine like the one behind us, which uses a variable speed hydraulic motor. He can buy a hydraulic motor to fit to a traditional axial fan sprayer. He can shut down the amount of air that's entering the fan via a Cornell donut. He can also start to look at other methods, such as adjusting the volume of air leaving the sprayer. This is some current research that we're doing at Cornell. The speed of the air is incredibly important when spraying. Too high an airspeed results in the droplets going through or going past the target. For example, when we're applying a fungicide to the bunches of grapes, the grapes present us with a buffer zone or a boundary layer. So as the droplets approach, then they will go around the bunch of grapes. By slowing down the air, we can therefore get the droplets to impinge on the actual bunches of grapes. So airspeed is crucial. Modern sprayers, like the one behind us, allow us to change the air speed, and modern research, or shall I say current research, allows us to change that speed while sensing the size of the canopy. Flagging tape may also be attached to a long wooden pole. This long wooden pole tied to the trellis wire, and then you can clearly see how much air is going over the top of the canopy, how much air is going through the canopy, and this then indicates that excessive airspeed will result in the droplets passing through or over the canopy. Water volume is terribly important. Too much water will lead to dripping off the leaves. Too little water results in not enough coverage. So there's an optimum level of water volume required per 100 meter row length. The modern method of calibrating the amount of water then is dependent on the canopy size and the amount per 100 meters of row length. It's equally important to understand that in early season we want very little water, and in full canopy we want a lot of water. This volume is also adjusted according to the amount of water we need to penetrate the bunch of grapes. Once the bunch is closed, the only way to get water into the bunch is to increase the water volume. And so all these factors must be taken into account. Traditional sprayers use hollow cone nozzles. There's a lot of interest in trying to improve the droplet formation that we get, and so farmers are looking at hollow cone nozzles of the new variety, that is where we have a plastic outer casing, a ceramic insert. The ceramic is required because it gives us longevity. The plastic insert is required because it shows us the color coding, and so we can quickly check if all the nozzles are the same size. Other nozzles being considered by some growers are full cone nozzles, particularly the angle of the full cone. This allows us to vary the distance from the canopy so we can match the circle of spray coming from the cone with the distance to the canopy. The other type of nozzle that gives us great interest are air induction nozzles. Air induction nozzles comprise of a tube, that is the outer body, with a hole drilled in it. As the liquid comes out through the nozzle, so air is brought into the liquid flow by means of a venturi. The air induction nozzle produces large droplets, about 4.5 times the diameter of human hair, and these large droplets are full of air bubbles. As the air bubble hits the leaf, the droplet goes splat. This gives us a degree of coverage, but certainly not the coverage we get with a fine hollow cone nozzle. So the benefit of the air induction is that the larger droplet or coarser droplet results in much less drift, probably 50% less drift. Water sensitive cards may be used to monitor where the spray goes within the canopy. These cards, yellow in colour, will turn blue when the water droplets hit them. The cards can be placed throughout the canopy and around the grapes. They place on the upper and lower sides of the leaves by using a simple staple gun, and can be wrapped around the stalk of a bunch of grapes by using another staple. This simple indicator will prove to the grower that the changes in both airflow and liquid flow are either working well or working very badly. Kaolin clay may be used to monitor spray deposition. This product is extremely safe, which is very important, and can be used in daylight to show where the spray has gone. Mixing the product with water and then applying it results in the leaves becoming quite white, looking really like snow has passed. And so you can clearly see where the droplets, which now appear as specks of white, where the droplets have landed, on the upper side, the lower side, in the bunch of grapes. And so this is a very useful tool for the grower. An alternative to kaolin clay is the use of a fluorescent tracer. There are a number of these products in the marketplace. When we mix this with water and apply the spray at night time, when it's dark, we can see where the droplets have landed. To illuminate the droplets, we use an ultraviolet, or sometimes referred to as a black light, and this shows us the fluorescence of the droplets. As it's so dark, and there's nothing else to look at but the fluorescence, this is an extremely good method of looking for spray deposition.